All right, you guys, it's Mrs. Buchholz here. Welcome back to another set of notes that we're taking in chemistry today. Again, our notes are always going to be 10 minutes or less, and we're going to be continuing on with something called nomenclature today. Now, you might be looking at the screen and wondering why I'm showing you the notes from last time. And the reason is I want to let you know that what we're doing today is essentially a continuation of this. So if you're going to take the notes today, you're going to want to open up your notebook and find these notes that you took, and we are simply going to add on to them. So we learned that nomenclature was a system for writing names and formulas for compounds. We learned the other day that binary ionic is made of two ions. That's where the prefix bi comes from, just like bicycle. And the two ions are cations, which are positive, and anions, which are negative. We learned how to write names for those formulas. We learned that we look on this thing called the ion sheet to write the names, and we simply look up the names on the ion sheet and write the names exactly as they appear here. One last thing that we learned about is that when we're writing these names, we get to ignore these little numbers if they're there. The 2, the 3, the 2, and we just write the names from the letters, okay, from the formulas. So what we're going to do today is we're going to learn how to write those formulas. We learned last time how to write the names. Now we're going to write formulas. And here's why I really wanted your notes out. You're going to go ahead and continue these on. We're going to have a letter B because we're still talking about binary ionic, but we're going to write formulas. Now this one takes a little bit more time. To write formulas for binary ionic compounds, it's going to take a couple little steps, okay? The first thing you're going to do is you're going to write down the symbol and charge of the positive ion. So where you're going to find that symbol and charge are on the ion sheet. The second thing you're going to do is you're going to write the symbol and the charge of the negative ion. And again, you find that on the ion sheet. And here's the part that's a little tricky. You may remember, again, looking back at these examples from last time, that sometimes there are little numbers and sometimes there aren't. You're going to have to figure that out in the third step. We're going to do something called balancing the charges. So we're going to balance the charges so the compound is neutral. And we'll talk about that. Balance the charges so the compound is neutral. So those are our three steps we're going to be using to write formulas. And the best way for us to learn again is with an example. So I'm going to have you write down EX, which means example, and we're going to write down the name of a compound that we're going to write the formula for. The compound we're going to write down is sodium bromide. Sodium bromide, and we're going to be writing our work to the right-hand side. So it says to write the symbol and charge of the positive ion, and you might be thinking, which one's positive? We learned the other day that the positive ion's always written first, so I'm going to look for sodium on my ion sheet. So I'm going to hunt for the name sodium, and this is what's going to take the longest. Now, the positive charges are all here. Those are the ones that are going to be written first, so I can look there first. There's sodium. The symbol for sodium is Na. The charge is +1. Do you see how that works? We look at what column it's in. So we're going to go ahead and write down Na over here. And then I'm going to write the charge +1 kind of over here, okay, to keep track of it. Now I'm going to do my second ion. So I'm going to look for bromide. So I'm going to go to my ion sheet, and it's going to be negative because we always have a positive and then a negative, and we're going to find bromide. So I hunt through all of these to find bromide, and it's right here. So again, I write down the symbol, which is Br, and the charge, which is -1. So we write down in our notes Br, and we write down -1. Now let's look at step 3. It says to balance the charges so that the compound is neutral. Now that word neutral we talked about last chapter. Neutral means that it has an overall charge of 0. No charge. We also learned that positive and negative charges cancel each other out. For every one positive charge, it can be canceled by one negative charge, and that's an important concept to know. So let's take a look at this example. I have a +1 and a -1. So, do those cancel each other out? They do. Another way to think of it is if I add those together, do I get 0? Or do I have the same number of positive charges as negative? Yes, I do. If that's the case, this is already neutral and my compound is good the way it is. I just need one of each of those. So NaBr is the formula for that compound. Now let's do another example. This time, let's do sodium oxide. And let's look this up. So I'm going to go to my ion sheet. Remember it says in step 1, write the symbol and charge of the positive ion. So sodium we just did, it's Na with a +1 charge. So I'm going to write Na over here and +1 here. Now I'm going to look for oxide on my ion sheet. Oxide is over here. Its formula is O, but its charge is -2. So I'm going to write O and -2. Now we have to figure out how to make this neutral. Is this -2 and this +1, are they going to cancel each other out? The answer to that is no, they're not. How do I make this neutral? Well, I have two negative charges. I'm going to look at it like this. This is a negative and this is a negative, and one positive. Right now, if I put those together, I'm not going to get 0. What do I need more of? See, this is where we get the numbers on the formulas. I need 2 of these. If I have another sodium, I'm going to write another sodium here with a +1 charge. Do you see that I now have 2 positive charges? So I need 2 sodiums to balance the charge. The way we show that is by putting a little 2 next to sodium in the compound. Na2, the 2 goes down below here, it's a subscript, Na2O. So there's my formula for sodium oxide. All right, let's do another. If you've got room over here, you can write them, or you can do them down below. Either way is fine. So let's do this one. Aluminum chloride. So again, first step, we go to the ion sheet and we find each symbol. There's aluminum and its charge, +3. So I'm going to write down Al +3. Now I'm going to look for chloride. So I look on my ion sheet, chloride is right here. It's Cl -1. So I'm going to write down Cl -1. So let's talk about balancing charges. This isn't going to work because the charge isn't 0. I have 3 positives and 1 negative. So what do I need to balance the charge? I need more of these. How many more do I need? Well, I need 3 of them total. Each one is -1. If I have a second one and a third one, do you see that I need 3 of these? That gives me a total negative charge of 3, and that balances the aluminum. So I need 3 chloride, and I show that with a 3. Now, one thing you guys might have noticed is that I don't write 1s in the formulas. Do you see in my first example, sodium bromide, I have 1 sodium, 1 bromide. In my second example, I have 2 sodiums, 1 oxide, but I didn't write the 1. We don't write 1s in formulas. All right, the next example is going to be, let's do calcium sulfide. So we look on the ion sheet and we find calcium. Calcium is Ca plus 2. So I write Ca and then plus 2 over here. Now I look for sulfide. Sulfide is S negative 2. And now I look at those charges. Do those equal 0? They do. Positive 2 and negative 2 together equals 0. So this is the formula for calcium sulfide. My last example is my trickiest, and we can go through more of these together in class. Aluminum sulfide. So we look up symbols and charges. Aluminum, we've already looked up, is Al plus 3. And sulfide is S negative 2. How on earth do we get that to equal 0? Right now we have 3 positives and 2 negatives, but I can't just add another sulfide because when I do, all of a sudden I have negative 4. So I add another sulfide, but then I have to add another aluminum. What's my total positive charge here? 3 and 3 is 6. My total negative charge is 4. I just need 1 more sulfide. Now I have 6 positives and 6 negatives. So how many aluminums do I have? I have 2 aluminums. How many sulfides do I have? 3 sulfides. And there is my formula. The other thing you're going to notice is I don't write positives or negatives for these numbers. They are just numbers without a positive or negative next to them, okay? All right, we're going to be doing more work with this. This last example, we might be showing you some little tricks for how to write that correctly in class, but this gives you a quick introduction on writing formulas. Thank you for listening.